Okay, hello everyone. Welcome to week 2 of our Cisco CyberOPS short course from IT Masters and Charles Sturt University. Week 2 will be focusing on Introduction to Cloud Computing and Security with our wonderful host, Matt Constable. Before we get started, we'd just like to acknowledge that IT Masters is bringing you this course from the lands of the Wurundjeri and Djaja people of the Eastern Kulin Nation, and acknowledge their unbroken sovereignty and pay respects to their elders and ancestors. Tonight, we've got Matt Constable presenting Introduction to Cloud Computing and Security, relevant to Cisco CyberOPS short course. You can find all of the recordings from week 1, as well as all of the recordings that are yet to be uploaded on the Moodle page, which is available to you at learn.itmasters.edu.au. That's also where you can find the forums to have discussions with your fellow participants, as well as having your written materials and any other relevant course materials that Matt, our wonderful mentor, has provided to you. If you haven't logged into that yet, if you're registered for the course, make sure that you're registered, which you can do at shortcourses.itmasters.edu.au. If you're having admin issues, you can email shortcourses@itmasters.edu.au. So that's for any issues with the new intranet system, accessing materials, questions about the short courses generally. All of those kind of admin questions, please direct those to the email address, and our wonderful short course admin team will be able to answer those very quickly. Q&A for tonight, feel free to pop questions that are specifically about the course content in the Q&A section. More admin procedural type questions, please direct those to the chat. Just make sure that your chat is being directed to everyone if you would like other participants to see it. And again, if you are not able to get your question answered, we do apologize. We can't answer all of the questions all of the time. Some questions might be something that Matt's kind of just about to say immediately after it's asked, and other questions we may not have time for tonight, but that is what the forums, which are again at learn.itmasters.edu.au, are for. So you can chat online with your fellow participants in those at any point throughout the course. Again, if we can keep the Q&A for questions that are specifically about the course content, that would be ideal so that we can keep track of all of them. So questions about the enrollment process, the relevance between the short course and the extended grad cert or masters and things like that can be directed either in the chat or to the admin team at IT Masters. If it's about courses generally, feel free to direct that to admin@itmasters.edu.au. If it's about the course or short courses at itmasters.edu.au. I know that there are some people that have had a little bit of difficulty logging in to the new system. It's a little bit of an adjustment period, but we should be able to get you all directed to that. And I can drop a little bit more information generally into the Zoom at the end of the course as well, after we do questions. The content for tonight will be for approximately 1 hour, and then including questions. It may run slightly over. If you need to leave at any time, the recording will be uploaded, so you'll be able to access that from about 24 hours after the course finishes. And I do believe that that is all of the housekeeping that we need to do for now. So I will hand you over without further ado to our mentor, Matt Constable. Take it away, Matt.
Thank you, Jack. Thank you for that introduction, and welcome back, everyone, or welcome to those of you that are coming to the first session and missed to your first session tonight, having missed last week. So last week we talked in depth about some basic cybersecurity fundamentals which are necessary to have an understanding of, to then be able to delve into the world of cyber ops and security operations centers. Tonight, we sort of expand on that and we look at cloud computing and some of the security issues around that, cloud service models, some responsibility models. And then we look at concepts around DevOps, continuous integration and delivery, and DevSecOps, and then have a little bit of a look at some of the different cloud security threats and how they are really not that far removed from what you would see in an on-premise environment. And then that will articulate, particularly that last little section on the security threats, will articulate really well with our content in our last week, where we do more in-depth analysis of the attacks and vulnerabilities related to DevSecOps and to cybersecurity and security operations centers in particular. And that's where there'll be a little bit of a practical element to this particular online course, and which I know some of you have been interested in. So let's move on and have a look at what we're looking at tonight. So first up, cloud service models. So we're in an age where the deployment and use of cloud solutions are becoming more and more popular. And this, I apologize if this little diagram may be a little bit small, but it's slightly larger in the actual, in the PowerPoint you can get up on Moodle. But what it's basically showing is from down this end in 2023, through to this projected use in 2050, we see a massive growth in the expectation of cloud computing usage. Now, at the moment, there are a lot of organizations. I've subcontracted and done some consulting with local government authorities and state government authorities in recent times. And there's a big drive, particularly here in Australia, to start moving from that on-premise environment to a cloud services model. And the main reason for that is to try to reduce capital expenditure and shift it over to the operational expenditure budget. There's a lot of advantages in terms of deploying cloud services, which we'll look at shortly. And primarily, we're focusing on where we're going to be, where we're spending our money. There's lots of different cloud services available, ranging from very large cloud service providers like Google and Amazon and Microsoft, for example, all the way down to smaller cloud services that might only provide you with storage, for example, rather than operating systems and applications as well. So there's a huge range, and in most cases, organizations that are transitioning to cloud will do so into a multi-cloud environment. So not a singular model, but a mixed model. And we'll see what that actually means in a few slides' time. With all that said, it then should be obvious that cloud security is becoming more and more important. It has been quite some time anyway. When you think about it, we've had things like iCloud, OneDrive, Dropbox, those sorts of cloud services for quite some time, but they're really a single-use sort of storage type solution rather than what we're actually talking about here this evening. And so security has been an established important thing that we need to talk about, but certainly it will be more so as we start to continue on in this age where we're going to these larger cloud deployments. The advantages of cloud service models are numerous, and these are some of the main advantages that businesses are looking for currently. So things like distributed storage. So having the ability to store your data across multiple physical systems or multiple data centers potentially. The ability to scale both vertically and horizontally. So in vertical scalability, we're talking about you might have, say, a single server with, say, 64 mega RAM and a terabyte of storage space and a couple of processors. To scale it vertically, you would simply add on to that particular service. So you might double the memory, you might double the processors, you might double the storage space, as an example. So you've still got a single server, but now it has a greater capacity. In a cloud environment, it's much easier to do that than it is in an on-premise environment where you would need to physically get spare parts and upgrade it or get a new server. In a virtualized environment, it's obviously much easier, and you don't have to do most of the work. That's handled by the cloud service provider. Horizontal scaling is where we go the other way, where we say, okay, we've got a single server with these particular specs. Let's now have another server with the same specs. So now instead of having one server, and choosing to upgrade it, we now have 2 servers and we split our services across those 2 servers evenly. Resource pooling is exactly what we're talking about. So cloud service providers have very large chassis-based systems or large hardware systems that are then provide us with virtualized servers, which can be scaled in either direction quite easily. And all of those resources on those big systems are shared by all or some of their customers at any one time. Accessibility is obviously a big advantage. We can access our cloud service from anywhere we have a valid, stable internet connection. Measured service simply means that we are provided a guarantee by our service provider for them to meet a certain standard of performance or security or both, and we can measure their performance based on that particular agreement. And automated management is really our ability to be able to scale both vertically and horizontally, to be able to increase the type of services that we have, to be able to deploy services rapidly and quickly. NIST, or the National Institute of Service and Technology, which is an American service or government agency that we spoke about last week, they have a special publication which compares cloud services and deployment models. And it's a good read if you're really interested in learning about cloud services and the deployment models in more depth than what we have time to cover in this particular week. In terms of essentials, within that document, within this particular document here, which is available on the short course site, NIST state that cloud computing should have these following characteristics, some of which we have already mentioned in the slide around our advantages. So we've got our rapid elasticity, our resource pooling, as measured service, and on-demand self-service really allows us to then simply say, right, well, we want to upgrade this system that we're got working here, and it will automatically happen for us rather than us having to buy new parts, take the server down, install the new parts, and bring it back up again. Broad network access is simply that accessibility from anywhere, from many devices. So the cloud deployment models that are most common and most important are public, private, community, and hybrid. So public cloud is any sort of cloud infrastructure that is offered for all consumers, regardless of industry and regardless of location, to be able to use. So the cloud infrastructure can be owned, managed, and operated by the consumer, depending on the service model we've got. It could be a third party, or it could be a combination of both those. Or it could simply exist in the premises of the cloud provider. A private cloud can work in a couple of different ways as well. So this can be something that you install yourself and you manage yourself, or it can be something that you can buy from a service provider, but that is explicitly for your use, or it could be for a particular purpose. A community cloud is similar to that in that it's provided as a service to organizations or a group of companies that have share some sort of common goal or share some sort of common industry, but it's not necessarily open for all members of the public to use. So often you might see a community cloud involved in, say, the finance industry, in medical industries, or in environments where you have multiple companies form partnerships to be able to help and service each other, and they share some common applications which can then be deployed through a community cloud. And then we have the hybrid cloud, which is really just a combination of any of all of these previous deployment models. And in all cases, the deployment of the particular cloud environment may be distributed across multiple sites. It could be on a single site. It could be managed by different parties. Different parties could have different responsibilities within that cloud provision service. Most typically, you will find generally a single cloud service provider will be responsible for it within the confines of the service model that you're using and the service level agreements that they provide. But it is possible that it can be distributed amongst quite a few users or quite a few different parties. The basic cloud models that we're going to look at, or service models, are software, platform, and infrastructure as a service. Now, there are other models, service models, that you will probably be aware of and that you will see in literature and commonly on the web, but these are the three that Cisco CyberOPS certification focuses on, and therefore we focus on in this particular short course. And this is what they look like. So software as a service, or commonly referred to as SaaS, is a cloud service model where the capability that's given to the end customer is simply to use the provider's applications and the provider's operating system and hardware. And all you need to provide as an end customer is information or data that you want to store or process on that particular platform. The applications, as with the other models anyway, this is similar, are accessible from all sorts of different devices. And that will be largely dependent on the application itself. So some of them will need to be, some of them will be accessible through a thin client interface, such as a web browser, or it may actually be a thick client at the other end or through a VPN type connection. In this particular service model, the customer doesn't have to manage or control anything within that particular cloud model. So the responsibilities for that service and the security and the performance of that service rest with the cloud service provider. The only thing the user or customer has to worry about is the data and information that they put into that system and use that system to process. Platform as a service, by comparison, places a little bit more responsibility onto the end user or the customer, because the cloud service provider is providing infrastructure, and in some cases, and it will be dependent on the actual service provider, some providers will also provide operating systems and be in control of those operating systems or be responsible for those operating systems. But as a consumer, you or customer, you can put your own applications and your own data on it and run with that. So this one's a little bit more responsibility to the end user and less to the service provider. But again, it will depend slightly. How far that boundary shifts will be dependent on the cloud service provider that you're engaging with and the service that you purchase. We'll break these down into diagrams in a minute, and it'll make, hopefully it'll make a little bit more sense. The last one we want to talk about is infrastructure as a service. And this is where the service provider will provide you with the infrastructure over which you can run your operating systems, whatever you choose, your applications and your data. And so you then become, as a customer, end user customer, you become more responsible for more of the software and more of the patching and the security and those sorts of things that's involved with this particular model. So in this case, less responsibility to the service provider, more responsibility to the actual customer. So the responsibility models break down in this way, and the next few slides will also help to articulate what we've just talked about with the basic deployment of the service models. Obviously, cloud service providers must take security and compliance very seriously, and there are some pretty serious requirements and guidelines, and there's some good best practices and numerous companies that will rate the relative security, performance and professionalism of cloud service providers. And of course, it's a very competitive environment with so many cloud service providers currently out there in the market, and going to be more and more as we progress towards that 2050 target of $700 trillion worth of cloud services out there. And so the way that these service models fit in terms of responsibility is as I was talking about before. So software as a service, most of the responsibility is on the cloud service provider in terms of security, access control, patching, maintenance, performance, all that sort of jazz. So all you've really got to do as a customer is provide the data that you're going to use on that system, or you're going to process on that system. Platform as a service is where the service provider will give you the hardware and the operating system. The delineation around the patching and things like antivirus and security of the operating system can sometimes be slightly different depending on the cloud service provider. But mainly, the service provider will look after all aspects of that in the underlying operating system. And then the applications and the data are then the responsibility of the customer. So in this particular model, you are, as a customer, you are taking back that responsibility for the applications as well. And that includes security and patching of those particular applications and access control. So there's not a great deal of difference between software as a service and platform as a service. Infrastructure as a service, however, is where the service provider will only give you the hardware. They provide you with the hardware. Everything else is your responsibility. So operating system and associated security, patching and access control. Same with your applications and same with your end user data. But ultimately, regardless of the model used, we have to understand that cloud security, and in fact, any measure of cybersecurity, is a shared responsibility. Even if we strip it back just to basic cybersecurity, which is, remember from our definition last week, cybersecurity is around security that considers the fact that our systems now are not just isolated and we interact with many other companies outside of our control. And so we have to consider our security best practices from that global perspective. Information security, on the other hand, is the understanding and application of security concepts that are standalone within our organization and do not rely on integration with anyone else. Regardless of whether we're talking info security or cybersecurity or cloud security or any other form of security you want to talk about, the responsibility is shared by everyone. Even the end users or customers have an obligation that if they see something or notice something that doesn't look quite right in terms of security, then they need to notify someone or take responsibility for that. So diagram form, and the next 3 slides, the diagrams are straight from the CyberOPS Associate official cert guide from Cisco. And this gives us a nice clear picture of what these different service models look like. So SaaS, you can see the customer's responsibility is the end user and the data that resides on those systems, whereas everything else underneath that is a cloud service provider's responsibility. Now, when we're talking about hardware, obviously we've got our physical network, our storage systems, and our servers are part of that. We also talk about the hypervisors, okay, which is our virtualization concept, the brains of our virtualized systems. And we can have type 1 or type 2 hypervisors. So a type 1 hypervisor is one that runs on a bare metal system as its own standalone operating system, if you like. And you install, or virtual machines are installed directly into that type 1 hypervisor, that bare metal operating system. A type 2 hypervisor is where we have a large server or large system which has an operating system running on it. So say, for example, Windows or some derivative of Linux. And then on top of that, we run a virtualization platform. So it might be something like VMware, for example. So an example of a type 1 hypervisor would be, say, ESX server or Microsoft Hyper-V, for example. A type 2 would be something like, well, if we're talking small scale, talking Oracle box, something like that, or VMware, other versions of VMware that have to reside on an operating system themselves. And they are quite different. Most cloud service providers will provide you with type 1 hypervisors. So they're not interested in running an operating system underneath, which has to be managed. They will give you a type 1 hypervisor and just provide you with virtualized machines within that. Operating system can be anything. You can run literally any operating system on a virtual machine, including some old ones like OS2 or Windows for Workgroups or anything like that if you wanted to do that for fun. All the way through the middleware, runtime, type coding, and the applications is handled by the cloud service provider in a SaaS environment. The only thing as customers is the people and the data. You can see with platform as a service, the customer takes over a little bit more. So just the applications, but everything else under that is provided by the cloud service provider. The only thing I would say with that is some implementations of platform as a service, particularly with the Amazon inside the Amazon stable, the customer can also opt to take responsibility for the operating system as well, so down to this layer here. But more typically, they will not take that responsibility. It will simply be the users, the data, the applications, and the patching, security, and access control surrounding those particular three entities for platform as a service. In infrastructure as a service, you can see there is a large chunk of the service model that is now taken over by the customer. So we've now taken the runtime, the middleware, the operating system, and the virtual network as well, but not the hypervisor. Okay, and that's because typically that is type 1 type hypervisor, which will be managed by the service provider themselves. Now, of course, you can run a model like this, or all of these layers here, you can run them privately if you want on your own chassis-based or large-scale system. And that would be a completely private cloud, not provided by a cloud service provider, but you could still provide the same sort of services to remote users. Okay, so that would be, if we think of things like remote access VPN, and we talk about this age of lots of working from home, particularly over that period where the world was run amok with COVID. There was a lot of organizations that were retrofitting VPN and cloudifying their internal applications for people to be able to access from home. And it was interesting because, for many years, people have said, oh no, we've got to have people in the office. We can't run things remotely. And we don't have the capabilities, don't have the technology for it. It's rubbish. That technology has been around for a long, long, long time. It's just that people haven't wanted to deploy that or simply spend the money on it or take the effort into designing systems that were able to do that. And that in and of itself brings about additional security problems that we haven't had in the past. So if you think, just to go off on a slight tangent for a minute, if you think about things like the recent Medibank, Optus, Latitude, a few other hacks that have happened in Australia in recent times, some of those have been because primarily, not talking about the actual technical implementation of the hacks or the attacks that were used, but a lot of the time these sorts of things are caused by the fact that companies decide that it's a really good idea to take internal systems that were made for internal use only and have been used for many years and decide that they would like to put the power of administration or some of the administration over customer data back into the hands of the customer. And that's not saying that's not an admirable thing, it is. But in doing so, they take systems that have been fine-tuned and built and designed to work internally, protected from the outside world with appropriate security measures. And they're now providing a front end to that that's been webified and enables people from the outside world to gain access to it. The problem with that is that security is often not taken into serious consideration. So we retrofit this webified front end onto these applications and think that they're going to be okay. And that's simply not the case. Security has to be considered from the ground up. And this will make, again, you'll see where I'm going with this once we get to the section on DevOps, continuous integration, continuous delivery, because it's a really important consideration that we need to consider. In terms of patch management in the cloud, with all of these models, responsibility for infrastructure and platform is shared between the service provider and the end user, because as you can see, we have shared responsibility over data, applications, operating systems. Okay, so in platform, we've got operating systems with the service provider, applications with the customer. In infrastructure, we've still got hypervisor, which needs to be patched as well. It's an operating system effectively. We may have other patches that are particularly around BIOS or integrated lights out, for example, network card drivers, that sort of thing for the servers. So all of that needs to be the responsibility of the cloud service. Everything above that will be the customer's responsibility. In the software as a service model, the cloud service provider pretty much takes all of that off we customers. So they have to worry about all the hardware and software patching all the way up the stack. In the infrastructure, the cloud service provider, as I said, just has to patch the hypervisors and the underlying drivers or BIOS or other middleware or firmware for the underlying servers. And in platform, they have to worry about the operating system and the supporting hardware. Everything above that is the remit of the client. In terms of our security assessment, so I'm going to look at some questions shortly, which talk about the different ways or the questions that we need to ask our service providers in order to be able to determine whether their service is going to be appropriate from us from a security perspective. Performance, SLAs, those sorts of things are a different kettle of fish. But in terms of security, there's several questions which we need to present to them to make an estimation whether we're going down the right track. In terms of our security assessment, once we've actually using a cloud service provider, that's also important as well. So we need to be able to perform or understand and perform vulnerability scanning and penetration testing. But in order to do that successfully, we need to understand what we can and can't do as a customer. And this is going to be determined by the service model that we're purchasing. So the more responsibility we have in terms of our patching, our operating systems, our applications, the more responsibility or flexibility, I guess, we have in being able to perform vulnerability scanning and penetration testing. The less responsibility we have with patching and deployment of operating system applications, so say software as a service where we only worry about the people and the data, then that ability or flexibility to do vulnerability scanning penetration testing is less our responsibility and more the cloud service providers. So they would have to provide us with vulnerability scans and penetration tests to ensure, to make us confident that they are providing the level of security that we are paying for and that we expect from our service delivery model. That doesn't mean that we shouldn't also be a little bit proactive and take some of that security into our own hands as well. So we can still do some vulnerability scanning. Penetration testing, probably not as much, okay? Because getting off a little bit off topic, but just to explain the differences, vulnerability scanning is basically that idea of performing reconnaissance. So what we're looking at is we're selecting a target system, in this case, our cloud environment, and we're running some scans over this particular environment to see if we can identify server names, for example, operating systems, and then patch levels of operating systems and applications. And then from that, be able to potentially identify certain vulnerabilities and therefore attack vectors into that particular cloud system. That's okay because that's mainly a passive operation where we just scan, we get some information, so we perform enumeration and reconnaissance, we evaluate that information, and then we determine, if we're an attacker, a course of attack after that time. As a person who's just doing a security scan to see if the security is up to scratch, we don't go that far. We simply do that passively, collate a report, and then decide what vulnerabilities need to be fixed and what we can sort of get away with. The penetration testing, however, is more invasive. So often it's good idea to get someone else to do this on your behalf. So if you bought a infrastructure as a service model, so you're responsible for the operating system upwards, then it's often a good idea to get someone else to do this on your particular behalf. Someone who is a certified vulnerability scanner and penetration tester, someone who knows what they're talking about. And often this is important when we have specific guidelines or we have specific legislative requirements that we have to adhere to, say something like payment card industry's data security standard, for example, or some ISO standard or other government legislation or requirements, depending on our industry. So while we can do it, depending on the service model, often better to get someone else to do it on your behalf. In any case, most service providers will provide you with detailed guidelines on how you can do that process. So where the delineation is between how much you can do and what they are responsible for. Regardless of that, there are lots of different threats that we need to consider when we move to a cloud model. For example, one simple one is we don't know where the data is in the cloud. It's in a cloud somewhere, but it has to reside physically somewhere in the world, doesn't it? And where that is usually completely out of our control and out of our access. So we have to take things like that into account, and we'll look more at that shortly. Your cloud provider should provide you a written agreement around the level of security and how they implement that security and the ways in which they verify that security through vulnerability scanning and penetration testing as part of your agreement. And if it doesn't match up with your requirements or what you want, then you can certainly either apply for compensation if something goes wrong, or alternatively, you can just go with a different service provider or go with a different agreement. DevOps, continuous integration, continuous development, and DevSecOps. These relate to what we've been talking about with respect to our software platforms and how we integrate those to the outside world. And this in particular, I think, is a really good snapshot, an introductory snapshot at what security operations centers are about and the sorts of things that they start to monitor. And we'll have a look at more of those in the next couple of weeks when we look at, particularly next week, when we look at access control models, and then a little bit more when we look at types of attacks and vulnerabilities the week after. The thing to remember, and I'll reiterate this again, I spoke about this last week, but for those of you that weren't here last week or haven't yet watched that particular session, I'll reiterate that the CyberOPS security certification is really more around monitoring, process, procedure, threat intelligence, incident response, policy, those sorts of things, rather than, if we look back on the old CCNA Security, where you'd spend a bit of time coding up routers with ACLs or a firewall or an IDS or something. While there is that component to it, CyberOps and security operations centers are more around how they use that tool to maintain a level of appropriate security within a monitored organization, rather than actually how to implement those particular systems. So rather than how do we set up a firewall, how do we set up an IDS, it's more like how do we use those to manage the environment in which we're monitoring. All right. So DevOps and others. DevOps is composed of a whole heap of technical things, project management and management type movements, applications, processes, policies, and procedures. Prior to the idea of DevOps, there were other models that were used to go through this system development life cycle sort of process. And one of the main ones was waterfall. So this is simply a development methodology that has somewhere between 5 to 7 different phases. and they all follow each other in a strict linear order. Each phase has to be completed before the next phase can be completed. Okay, before you can start the next phase. So phase 1 has to be completed before you go to phase 2. Now, what those phases are is not really, I'm not really too worried about that at the moment. There is a reading up on Moodle for you to have a look at around more detail around waterfall, but I'm just using it as a comparison to DevOps at the moment, and we'll see how it works in a minute. So it's called waterfall because each stage had to be finished before you could go to the next one. So it was literally like water going over a waterfall for the first time and cascading down the different levels. The other popular model was the agile development model, which a lot of you may have heard of waterfall too. A lot of you will have heard of this. And this is where we simply break up a particular project into several stages, and we collaborate with all the different stakeholders within that particular project. And we have this idea of continuous improvement and iteration at every stage. So we continually have this feedback loop going on with this particular model. In DevOps has developed as the outcome of an assortment of trusted principles, which are utilized in developing our software, in manufacturing hardware or software componentry, and even into the leadership component of our projects as well. It relies on bodies of knowledge from lean, theory of constraints, resilience engineering, different learning organizations and best practice organizations, from safety culture, from human factors, and many others. So what we're really saying, without going into a huge amount of depth on all of these different things, simply because we haven't got time, you could literally do a whole 4-week course just on these. What we're basically trying to say about DevOps is we're taking lots of different sources of trusted information, and we're using those to help us develop our outcomes, whatever they may be. Today's technology, DevOps value stream is what we call it, includes product management, so the ability to both develop and manage product once we've got to that outcome stage. Can be used for software. Primarily, it is a systems development lifecycle, so we primarily use it for software, but there's no reason that it can't be used for hardware or middleware or firmware or any other type of ware. It has a component of quality assurance, where we continually look at the stages of the project and how things are going and how things are working. Are they meeting expectations? Are they providing us with the performance, the security, or whatever other metrics we are monitoring? Are they providing what we think they should be, or providing it to a level that we are satisfied with? IT operations. So that means that we've got IT operations, which is at the core of Security Operations Center. So we have a team of IT cybersecurity professionals that are involved in this process, in monitoring it, in helping to manage it, in helping to move it further along, to helping this system development cycle continue around its iterative process. And obviously built into that from a security perspective, we have to have both InfoSec and CyberSec practices. So remember, InfoSec within a particular system or component, cybersecurity, how the security that relates to individual components interacting with each other. So it's a more holistic, global type view. There are 3 general ways or methods, if you like, that are used in DevOps. And the first one is just about systems and flow. So in other words, you make the work that you're doing, whatever that is, whatever you're developing, visible to the project team, to the people involved, by reducing the size, so breaking it down into effectively segments, into batch sizes. We reduce the intervals of work, so less time, and we prevent defects through our process of Q&A. Okay, so quality control. So we take small, digestible chunks of work, and we do a constant process of Q&A as we move along. The second way includes a feedback loop. So this allows us to constantly monitor and provide feedback to the different stakeholders involved so that we can quickly detect problems before they become a big problem, and allows us to be agile in our recovery, our detection, our recovery, and our mitigation of problems, and allows us then to feed that back in order for us to learn and subsequently improve our practices as we continue to develop. And then the last way is a process of continuous experimentation and learning, which is a really common method of learning in all walks of life. So in this case, we're conducting dynamic, disciplined experimentation, and we take risks. Calculated risks or educated risks, but we take risks. And this is probably the way in which most experimentation or most research in any area of study, but certainly in this area of study, this is the approach it takes. So we have to be agile in the sorts of operations or the sorts of tasks that we're performing, because depending on output of, so we perform task one and we get an unexpected output, we have to come up with a second task dynamically to determine, all right, what's the next step? Where do we go next? If we get an expected outcome from task one, then we can continue on perhaps the original path that we had in mind, or the original plan. So I sort of compare this particular method to that of typical research, where we come up with a broad and general hypothesis and plan, and we start to do some experimentation, and things go all right for a while, and we continue on our basic plan. And then eventually something strange comes up, and we might have to go off on a 45-degree angle, for example, or go off on a different tangent for a little while before we get back on path. Or it may in fact lead us down a completely new path altogether. Regardless of that, it allows us to build up a really tremendous body of knowledge, which we can then apply to subsequent projects, or in the case of security operations centers, other customers or other platforms. And so, as it says here, the creation of shared code repositories, if we're talking about software development, helps us to tremendously to achieve the ability to continuously experiment and learn from it, and then feed back into this system. So three different ways of doing it, but they all have some overlap one way or the other. And in some cases, you may in fact use multiple models. So continuous integration is simply a software development concept or practice where the people developing the code, developing these bespoke applications for us, will merge changes into a central repository of code several times a day. And this then allows us to go and interrogate these code repositories and start to develop an understanding of what's working, what's not working, allows us to pick up these faults as they occur, as we've said here in Model 2 and or Method 1, Method 2, primarily. Continuous integration supports continuous development because it provides a way for allowing us to speed up and automate the software release process. And this is something that's really important, obviously, because if you're developing a piece of software that you want to release to market, for example, and I know this is getting a little bit away from the cloud side of it, but if we're trying to develop a piece of software that we want to release out to market or release to a customer base, there's always a sense of urgency in it, isn't there? People always want it now, today. We want this functionality now, and we want it to work straight away. And so this process of CI and CD allows us to automate some of this process and allows us to get to the end market product more quickly, while ensuring that we can still maintain the appropriate level of security and testing to confirm through our quality assurance practices that we are getting what we need to meet the end outcome. With these particular methodologies, every time we change something in the code or something in our software, or really if you applied it to a hardware platform, something in the hardware as well, in the hardware or componentry you're developing, it should then automatically signal to someone, all right, we need to do a build and test, compile and test, power up test, whatever the test may be, in order to be able to confirm whether the changes we've made have given us the right outcome or whether they've given us something unexpected. So is it a change we want? Did it work? Is it something that didn't work? We have to roll back and continue on with our development, our testing, and that's then, in that method 3 we were talking about before, constant experimentation. So the stage is diagrammatically, and again, this is out of the CyberOPS Associate Official Certification Guide. This is really what we're talking about. Don't worry too much about these words down here. These are just an example. But basically, we have some source code, we build it, we test it, we deploy it, we repeat. Okay, we reiterate. There is some looping, depending on the method we use, 1, 2, or 3, as we were talking about before. This source, build, and test can take quite a long time, and there can be multiple iterations between these 3 phases before we get to the full deploy and staging or production. So staging, Q&A, and then production process. All right, cloud security threats. So in our last section for this evening, we're actually making excellent time this evening, which is good. We should have plenty of time for questions. I see there's a few already, and we'll get to those. Yeah, we're doing all right for time. Okay. So last little section. Well, it's not that little, but the last section. Cloud threats. So we've already spoken about the fact that we're going to move more and more in a cloud, and there's many potential threats. One of which is we don't know where our data physically resides. And we need to have that guarantee from our cloud provider as to the level of security that they're going to provide us. However, having said that, really the difference is the attack methods or the ways in which our systems can be attacked in a cloud environment are not that dissimilar. And the threat actors or the people who would attack us are exactly the same, whether we're using a cloud environment or an on-premise environment. The way they get to us may be a little easier through a cloud environment because it's accessible to the real world, but still, they are very similar. So we need to ask questions of our service provider to determine whether they are going to meet our expectations. The first of those is asking them who has access to our systems. So that is not just access in terms of being able to see the front page of our web service, for example, or our cloud service. It's literally around the access control. So who gets access to the system and at what level? And this will become really relevant next week when we look at access control models and the 4 main access control models and how they relate to each other. So we need to be able to have full visibility, not only from initially, so these are the people, this is a database of users and the access restrictions that they have, but we also need to be able to monitor that constantly as well and be able to update it as required depending on different circumstances as they change. We also need to know what are the regulatory requirements because they won't be the same depending on where you are in the world. So say, for example, if you're in, and I don't know, let's pull a country out. So say if you're in Guinea-Bissau, and hello, if anyone's out there is from Guinea-Bissau, I'd be amazed, but if you are, welcome. So if you're in Guinea-Bissau and you decide that you want to engage a cloud service provider that is in the US or Canada or Europe or Australia or any other part of the world, you need to ensure that whatever regulatory requirements they must adhere to, so they are legislated to adhere to, match what you want or match the requirements of your own country, because there's this issue of data sovereignty. Okay, so if I'm here in Australia there are certain requirements for different types of data. So particularly around, as we talked about last week, personally identifiable information or private health information. There are only certain ways in which we can store that and certain locations in which we can store that are legislated by the Australian government. And so, we can't engage with cloud service providers everywhere, depending on the type of data we're going to store. So we need to know what their regulatory requirements are and ensure that they match with what our expectations are or requirements are. We want to know, do we have the right to audit? And we should. We should absolutely have the ability to audit what the cloud service provider is providing us. And does it meet our requirements and regulations and governance? Can we do it ourselves? Can we get someone else to do it on our behalf? Again, that will be dependent on the service provider and indeed the country in which they are located and perhaps the local regulations and legislation. What type of training does the provider offer its employees? So this is really important because, as it says there, people will always be the weakest link in the security chain. And so we need to make sure that the users of that system or the administrators of that system, the people that monitor the system and ensure that the security and performance is up to scratch, the people who are deploying these services on our behalf know what they're talking about, know what they're doing. What type of data classification system do you use? Again, we'll look at that again in more depth next week with access control models, where we look at the difference between like the military standards, so top secret, I can't remember what they're off the top of my head anyway. Top secret, you've got confidential, you've got, open to anyone, the different classifications of information. And do they use a scheme that is commensurate with your requirements? How is your data separated from other users' data? So are we using a public cloud and everything's mixed together? Are we using a private cloud that's only just for us? Are we using a hybrid? How are the storage systems allocated? How are the customers allocated across those storage systems? How secure is the data from one another? Really, really important to understand. Do they use encryption? In most cases, the answer will be yes, but do they use encryption? We need to consider the idea of DLP, so data loss protection, which are simply systems that will protect our data, whether it's in storage, so through encryption, which in most cases, our data will be in storage. That spends most of its life in storage. But when it's in transit or when it's in being processed somewhere, it also needs to be protected. Encryption primarily used in storage space or can be used in transit as well. What are the service level agreement terms? Okay, so this is just a contracted agreement between you and the service provider to determine what level of security, what level of performance you are going to provide. What is the long-term viability of the provider? Now, this is really important because if you go with a service provider and suddenly a few months down the track, they go out of business and then they hand their data or they're bought out by another company or they hand all their customers over another company, you need to know that could seriously impact your particular deployment, could seriously impact your performance or your security, because your agreement with your current provider might not stand up with the new provider or the company that takes over. Or if they go bust completely, where's your data going to go? What services will you still have access to, if any? And if you don't, can you be guaranteed that you'll get access to your data or you'll get your data back, or will it just disappear? Will someone else, potentially nefariously, be able to gain access to it? So it's a really, really important question to ask. Will the provider assume liability in case of a breach? So whose fault is it if a breach occurs? This can be a bit of a grey area because depending on the service model, the liability may actually any fault for a particular breach may actually lie with the customer, particularly if it's your job. So if you're thinking you're buying infrastructure as a service and it's your job to secure the operating system and the applications, and you don't do that properly, then there's a difference there compared to software as a service where the provider has liability all the way up to the data. So who's going to take control of that? Whose responsibility is that? What is the DRBCP planning? So disaster recovery, business continuity planning. So disaster recovery is the planning and processes around we've got a major incident where our systems are critical. How do we get our systems back to full operational capacity? While we're doing that, business continuity kicks in. So business continuity is the processes and procedures we put in place while there is an incident in play and our systems are compromised in order to be able to perform business at some level, at least some level, so we're not hemorrhaging as much money as we otherwise would. Because cloud-based services are accessible via the internet, they are open to lots of different attacks. But is that any different to a on-premise system that has some sort of web connectivity? Potentially not, but it's a little easier. Okay, the ability to access or the time over which you can access these cloud-based systems is a lot greater. Okay, as more companies move to cloud computing, so as it becomes more popular, as it becomes more used into the future, obviously attackers are going to follow. Okay, where there is money, attackers will turn up. Where there is valuable information, attackers will turn up. Where there is benefit to be gained from some information or some attack, attackers will turn up. Some of the potential attack vectors that might be used include all these here, some of which we'll talk about in more detail in week 4 when we get there. But you can see that a lot of these attacks are no different to what we see in an on-premise environment or in a wireless environment or any other environment. So when we talk about the differences in security between a wireless environment and a wired environment, they're not really that different. The attack vectors and the attack threats and the attack actors are by and large the same. The principles are by and large the same. The only thing that's really different or can be really different is the mitigation techniques. They may have to be tailored depending on the environment that you find yourself in, whether it's cloud, on-premise, wired, wireless, whether you've got telephony, whether you've got a DMZ, whether you've got extranet partners. Okay, there's lots of different things that we need to consider in order to be able to have this full defense in-depth deployment of security. In summary, there's just a lot of possible attack vectors. There's a lot of different ways in which we can be attacked. Okay, that gets us to the end of our content for this evening. So your learning tasks this week, make sure that you, if you're not already watching this, obviously you'll need to, those of you out here that are not attending, they'll need to watch this particular lecture. There's a number of resources. There's several videos. There's some other resources that I've only just put up only minutes before we started this evening, all to do with each of the different components that we've talked about tonight. So that is cloud computing and the service models, the responsibility models, DevOps, CI/CD, DevSecOps, and then understanding in basic terms the different cloud security threats. So there's some resources to help you build a little bit more on those. There's also the YouTube video playlist that I put up at the start of the course, which is right up the very top of the Moodle page, which it gives you some access to more specific Cisco content around this particular module as well, and that can help build your understanding. And then when you feel ready, have a go at the Module 2 Quizlet, which will be open as of midnight tonight. Now, it will stay open indefinitely, and you can do it as many times as you like until you get 5 out of 5. So there, in the question bank, there's 10 questions, and this is the same for all weeks. There's 10 questions in the question bank. You'll get a random 5 each time you do the quiz. So obviously, the more times you do it, you're going to get exposed to the same questions. Once you get your 5 out of 5, it will then be marked as being complete. Well, you have to get 3 out of 5 to pass. Once you get a 3 out of 5 on any one iteration of the test, it will mark as complete, and that will then be one of the keys that you need to use to unlock the final exam at the end of week 4. So you need to do each of the weekly module tests, and pass each of those, so 3 out of 5 for each, in order to unlock the last final exam, which is 40 multiple choice questions, and you'll need to get 50% to pass that as well. All right, that's all I probably really wanted to say. So let's start to look at some of the questions.
Would you like to go
Well,
down the questions from top to bottom, or feel free
yeah,
to take that
I think
yourself?
so.
Or yeah,
There's oh, I'm happy to do that. Yeah, there's not really too many that we need to worry about, I see tonight. So we should get through them pretty quick.
no worries.
Okay, so first one, how does the difficulty of the short course exams compare with a master's or grad cert? The short course exams are pretty straightforward, so they're relatively easy. In terms of the master's or grad cert subjects, these are academic subjects, so the academic rigor around those particular exams is a lot more than the short course exams. Most of the subject exams, so for the master's or grad cert, will not be primarily multiple choice. This one is simply all multiple choice, A, B, C, D. There's a mixture of different questions on the other exams, so they might be extended answer, they might be scenario based. They could be multiple choice. In some of the exams, there's multiple choice. In other exams, there is multiple choice, but they're what's called W, X, Y, Z multiple choice. So they provide you with different statements that you have to evaluate. So all in all, the subject exams I would consider to be quite a bit more difficult than these short course ones. Okay, examples of community clouds that exist today. Yes, certainly. So one of the main community clouds that I'm involved with, and there's others as well, obviously, but community clouds are, as I said before, a community cloud is one in which we provide resources to a collection of distinct or discrete organizations, all for a common purpose. So think of research organizations, medical organizations, financial organizations, military installations, all can share community cloud platforms.
I can
And
actually
they are
give a specific example of a community cloud platform that I
over.
use on a regular basis, which is the VACUS system that is used by Ambulance Victoria to upload patient information to hand over to any and all hospitals or other ambulance services that one particular patient might come into contact with. So all that information is in the same place. And I do believe that is a community cloud.
That's a perfect example of community cloud. Well done. Yeah, good one, Jack. Thanks for that. So other examples would be things like the old ARNet, which was an academic and research network. Indeed, the internet initially really could have been considered a community cloud model because it was initially deployed for the use of education facilities, so universities, and for some military organizations. And they shared applications over the first iteration of the internet. Similar things happen today, obviously, depending on the organization. So there's another payment card systems type community cloud system, which allows the various financial institutions that do credit card clearing to access. That's an example of a community cloud as well. So there's, if you think of them within that sort of context, then you'll be able to find a lot more of them out there as well. But there are many research ones and scientific community clouds as well that people share information through. So it's in more often than not, as Jack has sort of mentioned there with the Ambulance Victoria system, it's a way of quickly and efficiently sharing information. So which certification would I recommend for cloud security? I don't really have a preferred one, to be honest. I think there are, at a high level, at a very high level, there's so Cisco have a really good cloud systems certification. Obviously, Amazon and Google also have some cloud certifications, components of which have security built into them. There's also, what was the other one I was just thinking of? It's just completely popped out of my head. Oh, so that was the other thing I was going to say. There's so ISC2, which are the vendors for the CISSP, which is one of the premier security certifications in the world. They have a cloud-based certification process as well. Any of those are well and truly fine to go through. I don't think there's, I wouldn't advocate one or the other. The only thing I would say is, and I say this to, if I say this with respect to most certification processes, I think it's good to go for something that's generic. And what I mean by that is it's not tied to a specific vendor. So while some certifications, so you look at Cisco certifications, right? It's all about the way Cisco does stuff and Cisco hardware and that sort of stuff. I think it's better in most cases, if you're starting out, to go through those generic certifications so you can understand the fundamental concepts and then take those concepts and apply them to whatever environment or whatever system or vendor that you're working with. If you have lived your life in Cisco land and that's all you ever work with, then certainly you can go down that track. So Stephen said, assume CapEx decreases and OpEx increases as we go from SaaS, PaaS to IaaS. Yes, indeed. Yes. So question is there. So as we get, yeah, correct. So as we go up the service model, so the more responsibility that goes onto the service provider, that shifts more money from that CapEx to OpEx. So the more that you're the responsibility for, so say for infrastructure as a service, you're responsible for the operating system. So you need to go and buy that and get your licensing and all that. So that's a capital expenditure rather than operational expenditure. So yes, as we go up the service model, as the responsibility increases for the cloud service provider, the shift goes from CapEx to OpEx, correct. Is DevOps requiring security as a code culture, or am I thinking of DevSecOps? They can be included in both. Is my answer to that. Whether that's a perfect answer or not, I don't know. But in my opinion, security as a code culture should be implemented in both. Which certification would you recommend for someone sitting in the OT space rather than the IS? Again, I don't necessarily like to specifically recommend any specific certification because I think it's really dependent on a little bit dependent on your own experiences and backgrounds, and obviously your own wants and needs and likes, and where you want your career path to take you. I'll give you the same general advice as I said before, and this is only my opinion, so it's not law. My opinion is that I think you are better off sticking with generic type certifications because what you really want to learn is principles and general theories, which you can then apply within any context. So I would always advocate, regardless of any course that you're doing, whether that be a tertiary level course or an industry-based course, always look at courses that provide you with the best bang for buck in terms of general principles, concepts, and theories, because that then allows you to have a really broad range of knowledge, which you can then go and apply to specific circumstances in a specific context. If, however, you go for something that's really specific, and I'm not hanging it on Cisco at the moment, but if you go and do a Cisco certification, which is very Cisco coding centric, then you may find, depending on the course, depending on the certification you're pursuing, you may find that the information contained within that is going to be really useful from a Cisco pathway because, I mean, let's face it, Cisco are market leaders, and they are very good at coming up with their own way of doing things, their own proprietary protocols, their own proprietary methods, which sometimes later on down the track become open standards, but it sort of pigeonholes you almost, if you like, into that particular environment and context. And it can be difficult to take those skills learned from that and apply it outside. Whereas if you go down a generic certification path, that becomes an absolute doddle to be able to do that, to say, well, I've got these big picture concepts and theories. I understand how, this particular technology works and this particular technology works. It doesn't matter what vendor I'm working with, I can now apply those skills. So that's the answer I generally give to those sorts of questions. So sorry I haven't given you a specific certification, but honestly, I think, in my opinion, that's the best approach to take. And of course, it depends on your background, your experiences, your wants, your needs, your goals, your expectations, all those sorts of things as well.
Great. Thank you so much, Matt. And thank you everybody for sticking around throughout the short course for tonight. We will have more opportunities for everybody to ask any further questions that they have and have plenty of discussions with your fellow participants on the forums. That's learn.itmasters.edu.au. Once again, just for people who are having any administrative issues regarding things like being able to log into the new system, please address any of your issues with that in an email to shortcourses@itmasters.edu.au. All of those recordings, written materials, and forums are available at the learn.itmasters.edu.au site. This recording will be uploaded within about 24 hours. And as Matt said, the Quizlet will be available from about midnight tonight. Once again, thanks very much, Matt. Thank you so much to Lily Nguyen for doing the back end and organizational kind of sorting of the short courses. And we will see you again, same time, same place next week. That is going to be at 8 p.m. Australian Eastern Daylight Time. So wherever you are in the world, whatever time it is where you are at 8 p.m. Australian Eastern Daylight Time, that is when we'll see you next week. Thank you, everybody, very much. Have a great rest of your week, and good morning, good afternoon, good evening, or good night. Bye, everyone.